I'll go back to the presentation. But I can tell in what the problem could be. If you think about the search page, then Internet Explorer would block a request that has a very clear cross-site scripting in it, and therefore the attack will not be successful. But Internet Explorer fails to block a request like this, where the first script tag is split over 2 parameters, and therefore a successful cross-site scripting, reflected cross-site scripting can still be done in Internet Explorer with the XSS filter on. Okay. And so it effectively filters reflected cross-site scripting attacks in one parameter, but it fails to do if you split it over 2 parameters, and it also doesn't block injection of HTTP. So you can think of when you find to evade the Internet Explorer 8 cross-site scripting filter, you could inject an HTML link, because that's pure HTML. It's not blocked by Internet Explorer. That includes a malicious code in one of the parameters, and because the link is reflected in the page, and when it's clicked by the user, it comes from the same origin as the site. So it's as the first row says, requests from the same origin are not filtered. So you could always do a two-stage attack where you inject a link, and if the user clicks that link, it will successfully trigger the cross-site scripting attack, executing the JavaScript that's in the URL. Okay. Now, the way HTTP request query string that has more than one parameter with the same name is handled differs between the many different components that process the URLs. And for example, you can, this is always a nice one to check. These are all parameters with the same name, and different platforms like Java, JavaScript, or the PHP server-side code or the ASP server-side code would say that the val1 parameter is a different value than the other ones, and that could lead to strange situations and to filter evasion, as we will see later on. Like the latest ASP.NET has some anti-cross-site scripting filters in there, and they can very easily be evaded due to the strange fact that ASP.NET concatenates all the values of the parameters with the same name, separated by a comma. And so this query string will result in that value in, oh, here we have the, here we have a real live example. So here is the ASPX server, and I'm sending to it the parameters that are all named par1 in this example, par1, 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 and the server says to me the content of par1 is first, second, third. So you see it appends all the parameters with the same name. This gives us a good filter evasion possibility, because the ASP.NET XSS filters fail to filter multiple cross-site scripting spread over multiple parameters. So this works pretty well, and you also directly evade the Internet Explorer 8 cross-site scripting filters because of spreading the malicious script over more than one parameter. Another very common vulnerability on the internet, and much more dangerous than the cross-site scripting, is the SQL injection. While the cross-site scripting gives you the ability to execute code on the client side, SQL injection gives you the ability to execute code server side or even further in the back end, and could give you access directly to sensitive data as user details, login details, and other things that are stored on the data store. There are some simple forms of SQL injection. We're going to talk about some version detection techniques. I think the slide is missing out. But, SQL special variables, functions, and tables, blind SQL injection, filter evasion, column truncation, how to route a box, and some tools that can be used for doing SQL injection. SQL is used to communicate with database systems, like, for example, PostgreSQL, Microsoft SQL, Access, MySQL, or any other database system that uses structured query language or standardized query language. Web applications often use database systems to store their dynamic